Okay, so we're looking at exercise 8E from the second year Stats and Mechanics textbook, and we're on question 5. Okay, so I am given the acceleration as a vector in terms of dependent upon t, and then I'm given some information about the velocity. So the initial velocity is 2j, and I'm told the initial position, and I'm asked to find the position. So to find the position vector, I'm going to have to get the velocity vector first. So what are we doing? Question 5A. Okay, so velocity is going to be the integral of the acceleration. So acceleration is 2I minus 2tj. So we've got 2I minus 2tj. Okay, so if I integrate that, 2 is going to integrate to 2t, and I'm going to have a constant of integration. Going to be really careful with that minus. So how am I going to do that? I think I'm going to put plus, and then minus 2t will integrate to minus 2t squared all over 2. So just minus t squared, and then there will also be a constant of integration there, and that's my j vector. And I am told that when t is 0, the initial velocity is 2j. Okay, so when t is 0, well, there is no I component, so straight off I can say C1 must be 0, because when t is 0, 2t plus C1 I equals 0. There is no I component, so C1 must be 0. So if I then look at the j component, so when t is 0, the j component is 2j, so that would be minus 0 plus the constant, so that constant must be 2. Okay, so my full vector for velocity is 2t, so that's 2ti, and then plus 2 minus t squared j. Okay, so that's just putting 2 into that. Okay, then, but I'm not asked about velocity, I'm asked about position, so I'm going to integrate that. Again, I'm going to have to worry about my constants of integration, so the position vector is going to be, so 2t squared all over 2 is just going to be t squared. And again, another constant integration to find. Perhaps here, let's call it a different letter because I've already used C1, so let's call that D1. And then integrating the j vector, so 2t is going to, so 2 is going to integrate to 2t, minus t cubed is going to integrate to, minus t squared is going to integrate to minus t cubed over 3, and then potentially another constant there. And then they tell me that the initial position is 6i. So this time round, I can straight off say that, so the initial position in the j vector is 0. So I can straight off say that d2 must equal 0. And looking at the I components, so when t is 0, r is, where am I looking? R is 6i. Okay, so that must equal 6i, so t squared, well, if t is 0, d1i must equal 6i, so d1 must equal 6. Okay, so my position vector is, so looking here, my position vector is t squared plus 6i plus 2t minus t cubed over 3j. Okay, and they do it slightly alternatively in the textbook, and I've kind of been trying out both methods through this exercise. So if you're a bit unsure about how I was getting my my two values for constants there, have a look at how they do it in the textbook, or look back through some of the earlier questions, watch through some of the videos, because there is a slightly different way of laying it out that might make a bit more sense. Okay, right, but I think I have answered A, so position vector of P at time t seconds, so let's just check that before we move on. T squared plus 6, 2t minus, yeah, we're good. Let's make a preview of what the next bit should be as well. So then, this bit's worth 4 more marks. Okay. So at time t seconds, where obviously t is greater than or equal to 0, a second particle has got that velocity, and they collide when t is 3. Okay, so they're going to collide when their positions are at the same point. So I definitely want to find the position vector of this new particle. So I'm going to have two different position vectors. So I'm going to add a subscript p to that answer so that I know that's the position of p. So the position vector is going to be the integral of the velocity. So I'm going to integrate this vector to find the position of q. So let's write that out. So 3t squared minus 4 minus 2tj. That's what I'm going to integrate. Okay, so I'll tell you what, I will do this, I lay this one out slightly differently when I'm finding C. Okay, so just in case, so if you're a bit unsure about how I did A, let's see if this might make a little bit more sense. It's just a matter of preference. So for this one, I'm just going to integrate the 3t squared. So that's going to integrate to 3t cubed all over 3, so just t cubed. Okay, and I'm not going to put a constant of integration there. So when I integrate the j, that's going to integrate to 2t squared over 2, so just t squared. And then I'm going to put plus d, where d is going to be a vector. Okay, right. So then they don't give me any more information. So they don't tell me the start position of q. In fact, that's what I've got to find. So I don't currently know. I haven't got any information to let me find d. Okay, but I do know they collide when t is 3. So when t is 3, they must be at the same I component and at the same j component. I'm going to need to be careful with that minus there. Okay, so one thing I am going to do is I'm going to rewrite vector d as ai plus bj. Okay, just so there's two unknowns to find. So in fact, I'm kind of ending up going back to how I did the last bit anyway, because I really want to get all of my I components together and all of my j components together. And again, I don't really like that minus there. So I'm going to actually put plus and then minus t squared plus bj. Okay, right. So I'm actually going to look at those versions. So when I'm looking at my I components, and they've told me they collide when t is 3. So I'm looking at the I component, the position vector for p. So that I component must equal that I component. So I know that t is 3. So 9 plus 6 is going to be 15. 27 minus 12. Okay, so a is 0. That's nice. And then if I look at the j components, so that would be 2t minus t cubed over 3 is minus t squared plus b. So when t is 3, that is going to be 6 minus 27 over 3. And that's going to equal minus 3 squared plus b. So if I add that 9 over I get B is 6. Okay, all right, so the full, it's supposed to be a subscript, it's a little bit smaller. Okay, so the full position vector for Q going back to this line, okay, is t cubed minus 4t, and we got that a was 0, so that's my I component, and minus t squared, and we got that b was 6, so plus 6j, and they want the position vector of Q at t is 0, so when t is 0, the position vector of Q, well, when t is 0, that is 0, and when t is 0, that is 6, so it's at 6j, okay, which I think we already saw was the correct answer. Yeah, so that's a good point. I should have some units there. Okay, it's quite a tricky one, that one.